Hello everyone. I hope my audio and video is clear to everyone. Please let me know in the comment section where my audio and video is clear to all. Please let me know. Okay. So let us start. Okay. So yeah, let us start. Actually, in the last session we have seen the vector. Now we are going to discuss the in this session. Now we are going to start with the projectile motion. So our kinematics pass will be completed. After that, we will go for the practice session. The next class. Okay. So let us start with the projectile. Is a very favorite topic of the all the competitive exams. Okay, so let us start with that. Just give me 1 minute. Just give me 1 minute. Just give me 1 minute. Sorry, this is some issue is happening. Just give me 1 minute. So sorry for the delay. Okay, so let us start with the projectile motion. Our heading is projectile motion. Okay, so let us start with that. In projectile, what we are going to do, we are going to see the different cases. Okay, we are going to see the different cases for the projectile, because there are the different cases in the projectile. So we will going to see like that. Okay, so first is ground to ground projectile. Okay, ground to ground style. Ground to ground. Yeah, sorry. Yeah, ground to ground projectile, that is the first case. So let us see that. Okay, so let us see that. So basically in ground to ground projectile, what is the scenario? The scenario is like this. Okay, the scenario is like this, correct? So basically I am throwing a one object from here to here, so it is going something like this. So what are the different types of questions that can be asked? Different types of questions are, suppose I have thrown with a velocity of u at the angle of theta. So first thing, you can take a horizontal component of this velocity ux, that is sorry, that is u cos theta, and this one is, that is u sin theta, correct? We will have a two cases, that is u cos theta and u sin theta. Now this is called as a h max, maximum height. If you see, this is the maximum height. One thing is very clear, one thing is very clear, that is u cos theta, that is, this is ux, u cos theta is going to be, is going to be the same, means this u cos theta, there is a, if okay, let ask you, what is the acceleration in x direction? There is a no acceleration. If you can see, acceleration is zero. Similarly, what is the acceleration in y direction? In y direction, we can say, sir, there is a gravity is there, g, so g is acting, minus g is there, correct? So due to this gravity, see, acceleration in y direction, that means the velocity in x component will be remain same, that at every point it will be u cos theta only, but velocity in y component is going to be changed. Now the question is that how it is going to be changed. Let us see that. So let us see that. First is time of flight. Okay, time of flight की बात करें, if you want to discuss the time of flight is basically what, from here to here, okay, for this whole distance. Okay, that is how much time it taken. I can say what is time that is taken from here to here is the same time taken from here to here. If you calculate that, this will come out to be 2u sin theta by g. That is the time of flight, first calculation. Second is the maximum maximum height. What is the maximum height? Maximum height is u square sine square theta by 2g. U square sine square theta by 2g. Maximum height. Okay, this is h max. Clear? And this will be equal to u square by 2g when my theta is equal to 45 degree. Correct? This is the thing. That is the first case. Second is range. Range means which range? Horizontal. Horizontal range. This thing from here to here. What is that? It will be given as sine theta 2 theta by g. This can be written as u sine theta into u cos theta divided by g into 2, that can be written as 2 times of ux into uy divided by g. So that is how we can find out these different parameters. Okay, these are the different parameters, correct? And you can see also one thing, when my range is maximum, so maximum range will be u square by, what is the maximum range? 2u square by g. The maximum range will be 2u square by, that is going to be the maximum range, because this has to be what? This has to be 1. Sine 2 theta can maximum can be 1. So the maximum range will be 2u square by g. Second thing, if I want to link the maximum range and maximum height from here, these two, I can say my r max is equal to 4 times of h max. My r max is equal to 4 times of h max, correct? That is a relation. Okay, that is a relation. My r max is equal to 4 times of h max. Clear? Second thing, so what we have analyzed till now, let us conclude that what we have analyzed that if you analyze properly, we have seen that my horizontal velocity is remain same, it is not changing, correct? You see, my horizontal velocity is remain same, it is not changing. It is u cos theta here also, u cos theta here. At every point it is u cos theta only. Okay, u cos theta and u cos theta. At every point it is same. My horizontal velocity is not changing, correct? But if you see about the vertical velocity, see initially here vertical velocity is maximum, then after that vertical velocity will start decreasing. Okay, start decreasing. At this point my vy, sorry, my vy equal to 0. At this point my vy start increasing, and at this point vy will again increase. So you can see my horizontal velocity is remaining same, but my vertical velocity is first decreasing, then becoming 0, then start increasing. That is a scenario which is going on. Okay, clear? Are you getting the point? So this is an important thing which you have to analyze from here to here. Are you getting the point? Clear? One more thing, the range for the complementary angles will be same. Means what I am trying to say, range for the complementary angles will be same. Suppose what is a range for the 60 degree, the same range you will get for the 30 degree. That is what I am trying to say. Okay, so one more thing, range for the complementary angles are same. Range for complementary angles are same. Means what I am trying to say, if suppose this angle is 30 degree, this angle is 60 degree. So as 60 plus 30 is what? 90, correct? For this both the cases, the range is same. Range for both the cases is same. That is what I am trying to say. Okay. So range for the complementary angles will be same. And what is the maximum range? The maximum range you can get is for angle 45 degree. Okay. This is the, for theta is equal to 45 degree, you will get R max. You will get R max, or you can say maximum range. You will get the maximum range for theta is equal to 45 degree. That is the case you will get the maximum range. Clear? Any doubt? So this is the few things. Now let us analyze the other things also. Important thing is that next important is the equation of the trajectory. Equation of trajectory. Like what is the equation of trajectory? Okay. If you see the equation of trajectory, what you will see, what you will find. Okay. See, equation of trajectory simply means that I want to write the equation for this. I want to write the equation for this curve. Okay, that is equation of this curve. Okay, equation of this equation of this curve. So for that, what I will do? Let us take some point here. Okay, this. Okay, so this coordinate let be x comma y. Correct. We know we have thrown with a velocity of u at an angle of theta, so this will be u cos theta and this will be u sin theta. Okay, no issue. Hello, this thing is given. Now I want to find the equation of this trajectory. So what is the equation I want? How I will write? First I will write in y. The displacement in is y, that is x. If you find, you will get y is equal to x tan theta minus 1 by 2 into g x square by u square cos square theta. You take some commons, you will get, if you take x tan theta common, you will get x tan theta into 1 minus x by r. That is another equation you will get. This is the equation of trajectory. Okay, this is the equation of trajectory. And second thing, if my r max is equal to 4 times of h max, we know this is the we know that r max, if r max is equal to h max, then my 10 inverse 4 is equal to theta, means theta is equal to 10 inverse 4. Simple. And last thing is the time of flight, can be written as 8 times of h max divided by c. I hope you are getting or understanding my this thing. Okay, because it is related to the equation of trajectory, and with respect to the equation of trajectory you should know how to write the equation. See, at any instant, suppose I want to ask you the velocity at this point, I ask you what is the velocity in x. So velocity in x will be, no doubt, it will be u cos theta only. But what is the velocity at y? So y will be, it will be velocity at y. If I ask you, then what will you write? Sorry, you will write v sin theta minus g into t. That is the equation you will write for the velocity in y. Because why I will write like this? because I don't know what is the velocity at time t, because there is acceleration, so the velocity will change. But in velocity on x will be always remain same, that is u cos theta. So if I want to write my total velocity, then I will write ux I cap plus uy j cap, correct? So what is ux? U cos theta I cap plus sin theta into gt into j cap. Okay, that is a equation of a velocity. Clear? Clear? So that is a final equation we can write. Now for finding this equation of trajectory, we have to just eliminate this t, and when we try to eliminate this t, you will get this thing. This is the from where we are getting the equation of trajectory. I hope it is clear now. Okay. So basically this chapter is very easy. If you know, if you have a command, good command on the equation of motion, you can solve this chapter very easily. Just you have to break into the two different motions. Just you have to try to see in separately the motion of x and try to see separately the motion in y, and then you analyze the things. That is a simple case. Okay. Suppose I can ask you in the same thing, in the same projectile only, I can ask you other things are also there. What are the other things I can ask? Okay, let me draw the image first, otherwise it will be confusing. Okay, theta ux uy, this is the velocity in u, correct? Okay, now this is h max, correct? This is h max. Now let us think at this point we will have a, again we will have a two velocities, correct? At this point also we will have a two velocity, correct or not? The net velocity will be like this, will be in this direction, but we will have a two velocity, that is for sure. Okay, we will have a two velocities at this point also. One will be at horizontal direction and one will be at vertical direction. Okay, suppose and then we have a net velocity. The net velocity at this point is tangent at any curve will give the, I have told you, tangent on the displacement curve will give you the net velocity, instantaneous velocity. Suppose this angle is alpha. Okay, now what is my question? First question is what is alpha? First question is what is tan alpha? So sir, tan alpha will be again same vy upon vx, correct? That is the first thing. Second thing I will ask you, what is a u? General velocity, if you want to write, you will write initial velocity. This is u means initial velocity, no? So this is u cos theta I cap plus u sin theta j cap. Okay, momentum is m is equal to u cos theta I cap plus u sin theta j cap. Okay, then second thing, velocity at a time, final velocity at a function of t, what it will become? I have told you that is u cos theta I cap plus, sorry, u sin theta minus gt into j cap, correct? Momentum at time t is equal to m into v vector, that is nothing but m u cos theta into I cap plus u sin theta minus gt into j cap. That is the second thing. Then vy sine theta into dt. So what is my v net? V net will be what? Simply ux plus uy. Okay, just you add, you will get v net. And what is the magnitude of v net? Magnitude of v net will be under root of, okay, by square. These are the small things which can be asked. I am just giving you a idea for this. Okay, these are just the small things that can be asked. I'm just try to give you one idea so that it will be easier for you to answer those questions. Clear? Anything else which can be asked in the projectile is, suppose like these are the small questions, okay, which examiner asks. So you should know how to apply the formula for this and how to solve it and how to get the solution. That is why I am telling you this. Basically projectile is finished. Now I am telling you what are the different types of questions that can be asked. Okay, so suppose we can ask at some point, suppose this point is s, this is x sy, this is xs, and suppose this is some angle beta and this distance is s. Now what is the first question they can ask you? Tell me first xs, u, and this angle, whole angle is theta. First they will ask you xs. That is simple, u cos theta into t, correct? Now what is sy? That is, you have to apply the formula u sin theta into t minus half gt square. What is s vector? S vector is into sy square, correct? And beta is equal to, if I ask you, that is sy by sx, correct? Are you getting the point? Are you getting the point? Okay, so this is how you can ask, you can answer this question if they ask you like this. Okay, second thing, what anything else they can ask? Like they are the potential questions which has been asked in the previous times also. Okay, now this is a scenario you see. There will be some time t1 where the height will be small h, and there is a some time t2 where again the height will be small h. My question is, what is the relation between that t1 and t2? So if you calculate, remember this t1 plus t2 is equal to capital T, first thing, and second thing, t1 minus t2 is equal to these are the two important relation between this t1 and t2, and lot of time they have asked you this question also. So if you know this equation now, you can directly find t1 and t2, no problem, if you know these two equations. Clear? Any doubt? This is also one potential question. This is also, these all are question in itself. Okay, they are the previous year questions which has been asked earlier also. It is better if you remember all these things. Okay, are you getting my point? These are the potential questions. There is a proper method to solve it and you get the answer, but it is better you remember some result. Okay, if some results you know, then it is very good, you can do the things very fast if you know the some results. Okay, next is one complementary case. One minute. This angle is theta, sorry, 90 minus theta, and suppose this angle is theta. Okay, these are the two projectiles are there. Let us suppose here are the two projectile, one is at theta, one is at 90 minus theta, correct? Now what are the different cases I can ask you? First thing, in these two cases, first thing, both the range r1 and r2 will be same. That is the first thing, because that I have told you earlier also. That is the first thing. Second thing, if you talk about time of flight, the product of their time of flight will be 2r by g. That is the first thing. Second thing. Third thing, t1 by t2 ratio will be given by tan theta. Okay, h1 by h2 ratio will be given by tan square theta. If you want, you can prove all these things, and h1 into h2 product will be given by r square by 60, correct? Second thing, h1 plus h2 will be given by u square by 2g, that is maximum range divided by 2. Second thing, h1 plus h2 will be directly proportional to u square, and h1 plus h2 is directly proportional to r max, that is maximum range. Okay, h1 plus h2 will be directly proportional to r max or maximum range. Okay, clear till here? Anyone have this? This is a one important case. There are the some results are related with this. One more thing I would like to tell you, that is a one more result. This very small result, just I will write it here. Okay, the result is very simple. Suppose the projectile is at theta. Okay, suppose, and this height is h max. Okay, and suppose I am drawing a triangle like this. This angle is alpha, this angle is beta. So what is the rule? State that tan theta is equal to tan of alpha plus tan of beta. Okay, tan of alpha plus tan of beta, correct? Tan of alpha plus tan of beta. That is a one result is there. Clear? So what I have seen, what we have seen till now, first thing we have seen about the ground to ground projectile. In ground to ground projectile, what we have seen about the few things. What are those things? First thing we have seen is the basic concept or basic idea of the projectile, in which we have seen about the few things. These are the important formulas we have seen. Okay, then we move toward the some understanding of the basic understanding of projectile, what is exactly happening, and then we move to a one result. Okay, then after that we have seen a small question, what is the equation of trajectory, and if you know the equation of trajectory, what are the different results we have seen. Then we move to a one important question, if suppose this type of things may be asked, then how will you answer these things. Okay, basically then we move to a one more question, this type of question, this type of question, and then we finally move to the complementary case, what is going to, because these are the potential questions, just I am teaching you the questions in a term form of results so that you can solve the questions very fast. Okay, just I am trying to teach you like that. Because if you in my class, if you're going for a course, suppose you are going for a detailed course, then I will teach you only this much. After that I don't teach you anything, I will just allow solve questions for you. But as it is a crash course, so you should know about the different results, so that your problem solving skill should be fast. So that is why I am telling you these results. Okay, now the next case is the horizontal projectile. Is the horizontal projectile. Horizontal projectile. Next case is the horizontal projectile. So let us consider a building which has a height h. Okay, height is h, and suppose at this point I am throwing a one object like this, so it will come like this, correct? Now the thing is that this has a horizontal velocity u, that is equal to ux, because it has a only horizontal velocity, there will be no vertical velocities there. Why? Because we are throwing it horizontally now, so there will be no vertical velocity. So this is equal to ux, horizontal velocity. Initial vertical velocity is not there. Okay, t is equal to 0, means if someone asks me what is uy, so uy will be 0, obviously, correct? Okay, so let us start the things. Suppose at this point there will be a velocity at this direction, that is v. Now this v has a two component. Okay, one is vy and one is vx. We can surely say that my vx will be same, yes or no? Because why? There is no acceleration in x, because there is no acceleration in x, but there is an acceleration in y, that is minus g. So I can say my vy will be not equal to 0, that is sure. Why? Because acceleration in y, so it will increase this speed. Okay, it will increase this speed, and this is the range. We will talk about this, what is that range. So first thing is that, okay, so first thing is that what is my vy at this point? So vy will be given as minus gt, correct? Vy will be given as minus gt. What is v? V is equal to under root of vx square plus vy square. So if you put this, vx is remain same, vy is gt square, that is a v net, that is a v net. Second thing, time of flight. If you calculate, it will be a famous result, that is 2 under root 2h by g. Everyone know this result, that is root over of 2h by g. So if I want to know the range, what I will do, I will multiply u with 2h by g, that is my range. Okay, my range will be root over of 2 square h u square h. So that is my range. So my range is this much, my time of flight will be this much, my u will be this much, v will be this much. So these are the results for this. Okay, are you getting my point? So this is the things. Okay, this is the things they can ask. Or one more thing they can also ask is, suppose at this point it came and hit the ground, correct? At this point it came and hit the ground. This is u, velocity, horizontal velocity will be u, and vertical velocity will be something, and this is my net velocity, correct? My question is that what is that vertical velocity? Okay, at this point what is the velocity? It will be under root of 2gh. If you remember my motion in straight line, this velocity will be root 2gh. So what is this velocity at this point? So this velocity will be v net is equal to, at this point, will be root over of u square plus 2g, correct? Correct. Next thing I can ask you is the equation of trajectory. Next thing I can ask you, the equation of trajectory. What is the equation of trajectory? Equation of trajectory, if I want to ask, write for this, what I will do, suppose at this point I am throwing an this is distance is x, okay, and this distance from this is y, and I want to write the equation of trajectory. How will I write? Just let us see. First thing I can see, my x will be, sir, u into t, and my minus y is equal to ut minus half gt square, correct? What is y velocity? This velocity is 0, so minus y is equal to minus half gt square. So minus minus will get out, you will get half g into x by u whole square, so you will get y is equal to g by 2 x square by u square, correct? This is my equation of trajectory which can be asked, okay? This is the equation of trajectory, correct? Okay, now one more important result. The projectile, the two bodies projectile, the two bodies in projectile see their path in a straight line. What I am trying to say with this, let us see. Suppose there is a one object is, this is my object, okay? Suppose this is my object and it is going like this with a velocity. Suppose it thrown a something, so it will fall like this, correct? What is the velocity of this object which is falling? It will also having a same velocity, correct? Horizontal velocity will be same, correct? Horizontal velocity will be same, correct? So when this object, see this one, this object 1 and this object suppose 2, see this object, it will see that this is also moving with the same velocity v. So what it will look like for this object 1? For object 1, for object 1, the object 2 is move in straight line, correct? For object 1, object 2 move in a straight line. That is the observation we can get from here. That is the observation we get from here, correct? Second thing, if suppose I have another person here standing here, then for this person and object 2 are doing straight line and projectile motion. Oh no, sorry. Projectile motion, correct? Clear? Okay, now the next case is the last case. What is that case? Suppose this height is h, okay, Okay, this is u, and suppose means what I am trying to say, I have thrown this object like this, not like this. I have thrown this object like this. So what will going to be happen? The path will be something like this. Okay, not exactly like this. It will be projectile motion only, but it will be, sorry, it will be projectile motion only. So you can see at this ground we have a projectile, correct? This is my h max, correct? This angle is suppose theta. Okay, let me draw this properly. U, that is theta, that is u. U sin theta. Acceleration in y, that is equal to minus g, correct? Okay, that is defined as a range. Okay, that is defined as a range. Let us talk about this point. Okay, for this point the velocity is v, this velocity is vy, that is u cos theta. And what is this velocity? I will write this velocity same, it is same like a projectile motion, you can write like that, u cos, u sin theta minus gt, same thing. Second, if I want to find time of flight, how to find the time of flight? Time of flight will be given as minus h is equal to u sin theta into t minus half ut square. Here you can find the time of flight also. So these are the different things that can be asked in this, and this is the last case. Okay, last case. I hope you understand this. Okay, I hope you understand this. Is that is clear to you? So in this class we have seen about the projectile motion. I hope you it is a not theoretical, it is very much mathematical is there, and lot of results are there. If you able to remember those results, then it is very easier for to solve lot of questions, and they are the crisp and important point which I have tried to told you in this session. In the next session we are going to either we were going to do the circular motion, otherwise we will solve some problems on the whatever we have covered till now. Okay, so till then, take care and goodbye. Thank you.